Hi everyone, good day. In this video, I'm going to walk you through the basics or the fundamentals of networking. This is essential to learn before you deep dive into AWS virtual networking. If you like this video, please subscribe to VSPARKZ channel. Here are the contents of this video. You are going to learn what is a network, why you need a network, what is a network device, what are protocols, and OSI layers. What is an IP and IP addressing. And we are going to learn about CIDR, CIDR, Classless Interdomain routing. And at last, we are going to learn about subnetting with some examples. Let us see what is a network. Two or more devices that is connected together to form a network. The connections can be of physical or wireless, or it can be both. You can ask me a question, why we need a network? We need a network to share the information between the devices in the network. So these networks can be of wired or wireless, can be small or it can be big based on its architecture and topology. LAN, WAN and metropolitan area network are some of the examples of a network. So this picture shows the simple diagram of a network. Here you can see the network is composed of wireless devices and wired devices. You can see the devices called switch, or router, wireless router, laptops and computers. So these devices are called as network devices. So the network devices all together forms a network. You can see towards your right, a laptop and a wireless router forms one network. Towards your left, the router, the switch and computers forms another network. So these two networks communicate each other with the help of another router. These networking devices has its own functionalities. Let us see one by one. The first one is interface cards, or you can say network interface cards, which allows the computers to communicate over the network with a low-level addressing system called MAC addresses. So these MAC addresses are used to distinguish one computer from another computer. So these MAC addresses are unique to each and every computer. Let's say if one computer has one MAC address, the same MAC address cannot be given to another computer. So these MAC addresses are also called as physical addresses. The next one is a switch. A network switch is a high-speed physical device that connects multiple computers or devices using packet switching. Switch are also called as switching hub or a MAC bridge. The main function of a switch is to receive, process, and forward data from source to destination. The source and destination can be different computers. You can see the picture of a switch in this diagram. And about routers. A router is a network device that forwards the packets between networks. You can compare a router to a traffic police. A traffic police routes the traffic from one side to the other side. Similarly, a router distributes the traffic from one network to the another network. You can see the same in the previous diagram. You can see a router sits in between two networks that routes traffic between left hand side network to the right hand side network and the vice versa. A firewall. That's a system designed to prevent unauthorized access to or from a network. Repeaters are the devices that will amplify your signal for long distance communication. So amplification, in the sense, it just increases the voltage of a signal. It does not do any other operation rather than amplifying your signal. Bridges connects network segments, which allows information to flow only to specific destinations. The last one is the gateway. So gateways are the network hardware devices that acts as a gate or a door between two networks. Let us discuss something about protocols and OSI. A protocol is a set of rules governed for the communications. In other words, it is nothing but the language using which the network devices speaks with each other. And the OSI. OSI stands for Open System Interconnection. That defines the 7 layers of networking. They are physical layer, data link layer, network layer, transport layer, sessions layer, presentation layer, and application layer. And the related common protocols are displayed in the slide. Few among them are Ethernet, that works in physical and data link layer, IP and TCP. IP stands for Internet Protocol, TCP stands for Transmission Control Protocol, that works in layer number 3 and 4. And you got the last layer, that is the application layer. And few protocols of application layer are HTTP, HTTPS, Telnet, and FTP. So this OSI is a reference model only, and we should be knowing TCP or IP protocol in detail. IP addressing and IP. IP stands for Internet Protocol, and IP address, it is a numerical label assigned to each device connected to a computer network. So these devices uses the Internet Protocol or the IP for communication. IP are of in two versions, that is IPv4 and IPv6. 6. That is version number 4 and version number 6. IP version number 4, that is IPv4, is composed of 32 bits. IP addresses are usually expressed in DDN format. DDN stands for dotted decimal notation. But at the back, these decimal points are interpreted as the binary digits by the computer networks. So all these things you can see in this slide. You can see an IP address 172.16.254.1. All the things, the decimal values got decoded into binary values. So if I say binary, everything will be represented in the form of zeros and ones. So this IPv4 address is expressed in DDN format. So this DDN format has a 32-bit length. Okay. This 32-bit length is divided into 4 compartments of 8 bits each. So these IP addresses are classified into 5 classes based on its usage. That is class A, class B, class C, class D and E. You can see the number of IP addresses available in class A is around 16 million. You can see it here. And the number of IP addresses that is available in class B is 65,000 around. And in class C it's almost 256 addresses. Also you can see the ranges of these IP addresses. That is class A, its range is from number 1 to 126. Class B is from 128 to 191. Class C is from 192 to 223. Class D is 224 to 239. Class E is 240 to 255. Okay. Among these addresses, there are few addresses which is classified as private IP4 addresses. The remaining addresses are called as public IPv4 addresses. A public IP address is something using which we can connect to the internet. And internet routable IP addresses are called as public addresses. The addresses which is not internet routable is called as private addresses. And these are the private addresses ranges. So these type of IP addressings are also called as class based IP addressing. So whenever I say class based or class full IP addressing, it means that the ranges or the classes, it's all fixed. There is something called as, in each and every IP addresses, there is something called as network portion and the host portion. Okay, so this network portion and the host portion we cannot change. Okay, if I consume class B range of addresses, the network portion is 128.0 and the host portion is x.x. So host in the sense, it means it is reserved for defining your computers, devices or network elements, whatever we discussed so far, it is a class full or class based technique, which is the older or a traditional system, which has some disadvantages. Okay, so due to these disadvantages only we are going for some other technique and that technique is called as CIDR, Classless Interdomain Routing. First, we'll see what are the disadvantages of the class-based IP addressing with an example. So you know that we have got some problems with class-based routing. One of the problems is this method is inefficient, which will exhaust IPs more faster. You can see an example below. See, you got class A address, you got class B, and you got class C range of IP addresses. Okay, where your network portion and the host portion will never change. Fine. Okay, so here is the example. You can see at the bottom. Suppose if an organization requires a network that can hold 2500 host machines. Okay, so the organization should use a class B license. Why? Because in class C type of addressing scheme, I can utilize only 256 hosts. Okay, but my requirement is 2500. So I should go for the class B license only. So if I purchase class B, then what will happen? Okay, we will be using 2500 hosts. But what about the remaining IP addresses? All are waste. So we are wasting around 63,000 IP addresses by holding a class B license. You are wasting it unnecessarily. So this is a serious problem. You are paying money, but you are not consuming it with the old technique or classical technique, or you can say a traditional technique. So to overcome this problem only, CIDR was introduced. CIDR, CIDR, Classless Interdomain Routing. But the IP addressing schemas, subnet calculations, all those things are almost the same. But the only thing you have to use a CIDR notation if you are going for CIDR. Okay. CIDR stands for Classless Interdomain Routing. The CIDR is based on variable length subnet masking. You can vary or you can scale up or scale down your number of hosts and your number of subnets. That is possible. Thereby, you are not going to waste that much IP addresses. So this VLSM, I mean the variable length subnet masking, makes the prefixes of variable length. An example of a CIDR notation is given below. It's nothing, just you have to include a slash and your CIDR length you have to mention. This CIDR length directly telling the network bits. Here I am consuming all the 172.19, I mean the 16 bits I am consuming. So which means that is the network portion, and the last 2 octets, that is 0.0, is my host portion. You can also vary this. I can use 16, I can use 17, I can use 18 for in class B IP addresses. But using the traditional technique, I cannot change this. If it is 16, it's 16, it's fixed. It is only fixed length. But whereas if you are using CIDR, it is variable length. That's the only difference. So using this CIDR, we are making this IP addressings etc. more efficient than the traditional one. Fine. The next thing is subnetting. What is subnetting? Subnetting means subdividing a network into multiple pieces of networks. Here are the benefits of doing a subnetting. Its routing is efficient, it enhances security, it reduces the risk of the broadcast domain. You can see a diagram below. Okay. You can see the network 172.19.0.0 is having machines that belongs to test environment as well as the production environment. This is a small picture, whereas in the real-time scenario you got thousands and thousands of machines where the management and complexity is too high with a single network domain. Now, in this picture, you can see that entire network, that is 172.19.0.0, is divided into two pieces of sub-networks. Okay, these sub-networks is called as subnets or subdivided networks. And this reduces the complexity, management and troubleshooting. Let us see how to do a subnetting. First, you have to identify the network ID portion from the IP addresses. Usually it is identified with classes, subnet mask, or you can identify from the CIDR bits. So in this example, I have used the class B IP address with a CIDR range of /16. That is 172.19.0.0/16. Here, the first 16 bits are the network ID portion that I identified from the CIDR bit. So CIDR bit shows that the network portion is 16. I mean the first 16. The next 16 portion is the host portion. You can do the subnetting only in the host portion. So now I am going to subdivide this entire network into pieces with the help of this host ID portion. Let us see the first example of it. Here I am going to consider the 17th bit of my IP address for doing the subnetting. The 17th bit is the first bit of your host portion. You know that subnetting should be done only in the host portion. In the 17th bit, I made it as X for your reference. So you can see that X here. Okay. So I can place either 0 or 1 in that X portion, which means I can have two combinations of subnets as shown in the below. 0 or 1. If I place 0 in the X place, I got subnet number 1. You decode these binary bits into decimal. You will be getting this. That is 172.19.0.0. You convert 0, 0, 0, 0, 0, 0, 0, 0. That is 8 zeros into decimal. You will be getting 0. Now you should see the CIDR bit. CIDR bit for subnet is /17. Why? Because now the 17 bits becomes the network for that subnet. We are dividing the network into two pieces of subnets. The first subnet's ID is 0 and the second subnet's ID is 128. You convert this 8 bits, that is 1 0 0 0 0 0 0 0. You convert this thing into decimal, you will be getting 128. So you got the remaining 15 bits, that is from this 0 to this 0 for host portion. I mean for your computers or devices. So in each and every subnet you can have 2 power 15, that is 32,000 around IP addresses available. So exactly to say 32,000 768 IP addresses are available in each of these subnets. In this case, we consider only one bit, that is the 17th bit for subnetting, which has resulted in two subnets with 32,768 IP addresses in each subnet. The same is depicted in a picture. You can see this picture. You got a big network, that is 172.19.0.0/16, which is divided into first subnet and the second subnet. The subnet calculations only we have seen in this picture. So in each and every subnet, we have to connect our computers with the help of a switch. You can see this blue color box is my switch. So in each subnet, I can have 32,768 IP addresses. So those IP addresses are used for each and every computer. So it will be better if you see another example. But in that example, I am going to consider a lot more bits for subnetting. Here is another example where you are taking the entire third octet. That is, this octet entirely you are taking for subnetting. Exactly to say, you are taking the 17th bit number to 24th bit number for subnetting. Okay, I am marking the the third octet as XXX fully. Let us see how many subnets and the number of hosts in each subnets are available. If you are taking the entire third octet, that is 8 bits, the permutation and combination of binary bits will result in 256 combinations. Okay. You can see the combinations 0, 0, 0, 0, 0, 0, 0, fully 0. Another second combination is 0, 0, 0, 0, 0, last one is 1. You convert this 8-bit number into decimal, you will be getting 1. And the third combination is 0, 0, 0, 0, 0, 0, 0, 1, 0. Okay. Similarly, you can go ahead and hit the combinations up to all ones. So beyond this, there is no combination. Okay. You convert this 8 bits into decimal, you will be getting 255. You convert this bit into decimal, you will be getting number 2. And the same is depicted in this picture. So before seeing this picture, you should be knowing the last 8 bits is used for host IDs or host portions. So here only you should configure or number your hosts. You can see the CIDR range for subnets becomes 24 because we have taken all the 8 bits, the third octet fully for making the subnets. So for each and every subnet, the CIDR bit should be 24. We are just representing the net indirectly, saying the network bits for subnet is 172.19.1, that is 3 octets. 3 octets is equal to 24 bits. You can see the same in this picture. So you got a network 172.19.0.0/16. This network is subdivided into 256 subnets. First subnet is 0.0, second subnet is 1.1, third is 2.0, fourth is 3.0, and the last one is 255.0. So all these subnets possess the properties of this particular network. Why? Because this subnet, for instance, 172.19, it has the residue of the main network. Similarly, this has the residue of the main network. This is also having the residue of the main network. For comparing, you can compare the same thing with a cake. You got a birthday cake. All alone you cannot consume it. What you are doing, you are just cutting into pieces. First piece of the cake possesses all the properties of the cake, starting from flavor, color, taste, sugar, etc. But it is piece number 1. Similarly, piece number 2, 3 and all. Same way, you got a network and you divide into piece number 1, piece number 2 and piece number X and so on, based on our usage. I can cut my cake. If I need more cake, I'll cut the piece into a bigger one. Similarly, if I need more number of hosts, okay, I'll cut the subnets into a bigger one. I mean, in one subnet I can have more number of hosts. So in this particular subnet I can have up to 256 IP addresses as free, but few addresses you cannot use because those addresses are special addresses. Say for example 0.0.0.0, it's not an IP address, and 127, it's a loopback IP address. You cannot use those IP addresses. And for switch, you will be assigning one IP address, so that address also you should not use. So these IP addresses are the special IP addresses, you should not use it. So now you should have been known, or you should have been familiar with subnetting and how to do subnetting. So here's the summary of the things what we have discussed so far. So we have discussed what is network, what is a network device, what is protocol, what is OSI layers. Okay, 7 layers of networking is called as OSI. What is an IP address? What is an IP first? What is CIDR? So what is the problem before CIDR? And at last we discussed about subnetting, how to subdivide a big network into bits and pieces with 2 examples. So if you like this video, please subscribe to VSPARKZ channel. And thank you from VSPARKZ.com. Thank you for spending this much time to see this video. Okay, thank you again. Have a great day ahead.